Yeah, Bhavna, meanwhile, if there is anyone is waiting in lobby, just allow them or admit them to join the session. Okay, please do that.
Okay, sir.
Yeah, thank you. Screen share ಮಾಡ್ರಿ Bhavna. Just be on that slide, title slide. Yeah, put it on a slideshow. Manjunath sir, yeah. Venkatesh sir, shall we start the session or
Yes, sir. We
once
need to
I
check whether sir has joined or not. Irana, sir.
yes sir, yes sir, yes sir. Actually, I have sent the link.
Yeah, I have also sent him, sir. I will call him and ask him to join, sir. Wait.
Yes sir, yes sir. Please do this. Okay, we have enough participants as well here. Venkatesh sir, I hope I'm audible.
Yes, sir. You're audible, sir.
Yeah, sir. We start, sir. We'll start. Definitely. Yes, sir. I think now the Mahan sir has called. I think they'll join, sir. Definitely they'll join.
Okay, sir. Okay.
Till then we will have our session. So it will take around 10 minutes, sir. 10 minutes. They'll join.
Start, sir.
Yes. Yeah. Shrutika, please take over this session. We can begin.
Yes, sir.
Shrutika. Yeah.
Hello, good afternoon, everyone. I'm Shrutika from 8th Electrical Department. So, a warm welcome to you all for this online workshop on prototype process design and development prototyping. Now, here is a VT. Please have a look over this VT.
Established in 1997 with the holy blessings of founder President late Dr. Tontadarya Mahaswamiji and now headed by Dr. Tontadarya Mahaswamiji. Approved by AICT in New Delhi and affiliated to Visvesvaraya Technological University, Belagavi, offering 5 undergraduate programs: Computer Science, Civil Engineering, Electronic and Communications, Mechanical Engineering, Electrical and Electronics Engineering, Training and Placement Cell, Industry Institute Interaction Cell, and MSS are provided. Placements in TCS, Infosys, Wipro, Mindtree, NTT Data, and many more. Central Library with a 300 seating capacity, having more than 40,000 books, e-resources with a language lab and bookbank scheme. Cisco Networking Lab and IIT Mumbai supported e-Yantra Robotics Lab in campus. Separate hostel for boys and girls, van, ATM, medical facility, bus facility, canteen, stores on campus. Active participation in outdoor and indoor sports, volleyball, gym, table tennis, and many more. Join Tontadarya College of Engineering to create your bright future.
So, the intro song by Hazra from 8th Electrical Department.
Thank you, Shrutika. ದೇವ ನಿನ್ನ ಇರವ ನಂಬಿ ಜೀವಕೋಟಿ ಸಾಗಿದೆ, ಕಾವನೆಂಬ ಅರುವಿನಲ್ಲಿ ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ದೇವ ನಿನ್ನ ಇರವ ನಂಬಿ ಜೀವಕೋಟಿ ಸಾಗಿದೆ, ಕಾವನೆಂಬ ಅರುವಿನಲ್ಲಿ ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ಸತ್ಯ ಶಾಂತಿ ನಿತ್ಯ ಕಾಂತಿ ಧರ್ಮ ಸಿಂಧು ನೀನು, ಕಷ್ಟದಲ್ಲಿ ಕಾಮಧೇನು ಕರ್ಮ ಬಂಧು ನೀನು. ಕಷ್ಟದಲ್ಲಿ ಕಾಮಧೇನು ಕರ್ಮ ಬಂಧು ನೀನು. ದೇವ ನಿನ್ನ ಇರವ ನಂಬಿ ಜೀವಕೋಟಿ ಸಾಗಿದೆ, ಕಾವನೆಂಬ ಅರುವಿನಲ್ಲಿ ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ಸರ್ವಧರ್ಮ ಕೇಂದ್ರ ಬಿಂದು ನೀನೆ ಜ್ಞಾನ ಕಿರಣ, ಪರ್ವಕಾಲದಲ್ಲಿ ನಿನ್ನ ಭಯವೆಮ್ಮ ಹರಣ. ಪರ್ವಕಾಲದಲ್ಲಿ ನಿನ್ನ ಭಯವೆಮ್ಮ ಹರಣ. ದೇವ ನಿನ್ನ ಇರವ ನಂಬಿ ಜೀವಕೋಟಿ ಸಾಗಿದೆ, ಕಾವನೆಂಬ ಅರುವಿನಲ್ಲಿ ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ತೋರದಂತ ವರದ ಹಸ್ತ ನಮ್ಮ ಶಿರದ ಮೇಲಿದೆ, ಕಪ್ಪು ಛಾಯೆ ಮೋಹ ಮಾಯೆ ಅರಗದಂತೆ ಕಾದಿದೆ. ಕಪ್ಪು ಛಾಯೆ ಮೋಹ ಮಾಯೆ ಅರಗದಂತೆ ಕಾದಿದೆ. ದೇವ ನಿನ್ನ ಇರವ ನಂಬಿ ಜೀವಕೋಟಿ ಸಾಗಿದೆ, ಕಾವನೆಂಬ ಅರುವಿನಲ್ಲಿ ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ಜ್ಯೋತಿ ನೀನು, ಪ್ರೀತಿ ನೀನು, ನೀತಿ ನಿಯಮ ನೀನು, ಶಬ್ದ ನೀನು, ಮೌನ ನೀನು, ಮಹಾಮಯನು ನೀನು. ಶಬ್ದ ನೀನು, ಮೌನ ನೀನು, ಮಹಾಮಯನು ನೀನು. ದೇವ ನಿನ್ನ ಇರವ ನಂಬಿ ಜೀವಕೋಟಿ ಸಾಗಿದೆ. ಕಾವನೆಂಬ ಅರುವಿನಲ್ಲಿ ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ದೇವ ನಿನ್ನ ಇರವ ನಂಬಿ ಜೀವಕೋಟಿ ಸಾಗಿದೆ. ಕಾವನೆಂಬ ಅರುವಿನಲ್ಲಿ ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ನಿಮ್ಮ ಚರಣ ಕೆರಗಿದೆ. ಥ್ಯಾಂಕ್ ಯು ಎವ್ರಿವನ್.
Yeah, thank you. And here is a small introduction about this innovation cell. And now I will welcome Dr. Venkatesh Bhandge sir, who is the president of this innovation cell.
A very good afternoon to all of you. Am I audible, Bhavana?
Yes, sir, you are audible, sir.
Okay, thank you. So I take this opportunity to briefly introduce the EIIC cell and the different activities in the cell. The Entrepreneurship, Innovation and Incubation Cell was established in our institute in the year 2019-20. Next slide. Next slide, please. Okay, the main intention of this institution's Innovation Council is it is an initiative taken by MHRD's Ministry of Education's Innovation Cell, Government of India. The main purpose behind this is to the higher education institutions should have innovation, entrepreneurship, and startup qualities in their institute, along with the usual teaching learning activities. So, to promote the innovation activities, the cell is striving to bring in such culture in the higher education institutes. And in our college, we have established the IIC cell during the year 2019-20, and this is the idea of our institute. Next slide, please. So these are the different office members, office bearers of our Institute Innovation Council cell. So which is headed by our principal sir, and these are all the remaining cell members. Next slide, please. So as the Institute Innovation Cell consists of faculties, the students are also very much essential part of this, and these are some of the names of the students who are leading different activities in this cell. And along with this, there are many more students present in the cell who are actively taking part in the activities of the innovation cell. Next slide, please. This is what is the certification received by our institute during the year 2019-20 by the Innovation Council of MHRD. We have received a initial star rating for our institute. Next slide. The types of activities from the IIC are categorized into three types. So the first type is IIC driven activity, so which are basically the calendar based events which are provided by the Innovation Council only. We just have to plan them and execute them. The second type of activities are MIC driven activity, that is ministry only will be conducting those events and we just have to participate in the events. Slide sharing has stopped probably. The third, can you restart sharing the slide?
Yeah, Bhavana.
The third type of activity in the cell is self-driven activity. The self-driven activities are the one which will be solely planned and executed by our institute only. So we have the responsibility and we'll be having freedom to conduct our own activities. So under the cell, so till the slide comes, I'll just continue the presentation. So under the cell, we have conducted different activities and all the faculty coordinators and student members are actively taking part in the successful conduction of the events. So starting from the upgrading the Innovation Council.
Sir,
Next,
I
next
hope,
slide.
yeah.
Yes. Previous slide.
Yes, sir.
Previous to this.
Yes, sir.
Slide number 7. Yes, sir. Yes, sir. So we've starting from the upgradation of the IIC event, we have conducted different events in our institute, and the next event was Ideathon, which was self-driven activity, and then we had an event by the successful innovator, then the MIC-driven activity in the sector of agriculture, and then we had MIC-driven activity called Kapila, which was hosted by the Innovation Council. Next slide, please. So these are some other activities. And the activity number 6 is motivational session by successful entrepreneur or startup founder. So one thing to be noted here is the resource person, whoever is we have today, Mr. Rudraradya sir, he was the same resource person for this event, and we had a very good session by sir, and because of which we are having him once again with us. Next we had an IIC event, and all these are different events which we conducted in the innovation cell. Next slide, please. Yes, again there are 2 MIC activities and 3 IIC driven activities. Next slide. Yes, totally the innovation cell has conducted 22 different activities, including today's event. And out of 22, there are 16 IIC driven, 4 MIC driven, and 2 self driven activities have been conducted. And still, there are many more events to undergo under this banner of IIC. Next slide, please. The key implementation, what has been achieved by the IIC cell since its beginning, we have successfully framed and implemented the National Innovation and Startup Policy in our college, and Professor Jagadish Shivangutti sir is coordinating the NISP. And under this NISP policy, various facilities are given to students and faculty members also. If student wants to start their startup in the college itself, so we have made our own facility, and we will give the opportunity for the students to begin their own startup once they complete their engineering. And similarly, the faculties can also have their own contributions towards entrepreneurship in the institute. And we have also nominated 3 of our faculties for the Innovation Ambassador Training for the year 2021, and which is an ongoing activity from 36 2021 to 37 2021. And Professor Santosh Kumar Kandagal, Professor Chambamma K, and Professor Manjunath Kammar have been nominated from our institute for the Innovation Ambassador Training. So with this brief introduction of the Innovation Cell and its activities, I will hand over the session to Bhavana. Please continue the session.
Yeah, thank you, sir. And introduction about the today's resource person by S.S. Kangal, sir, Assistant Professor of Electrical Department, and who is the member of Innovation Cell.
Yeah, thank you, Shrutika. Thank you so much. So today we have resource person, Mr. Rudraradya Panchakshariya. He is founder and director of CED Labs, and he is located in Bangalore Urban in Karnataka. Here we have brief points of our resource person. He is having more than 20 years of experience in domain of avionics and embedded systems, power electronics, flight engines, building fire safety, flight management system, and railway systems. And even sir has strong experience in embedded product development, mechanical as well as hardware and software development, and integration and testing. And even sir has worked with systems like flight display systems, flight management system, overheat detection system, auxiliary power system for aero, flight power distribution system, and integrate power model. And even full product development, owned full responsibility of developing the in-seat power supply, airborne 400 watt power supply for passenger entertainment, and even driven this product development activities from kickoff till the product commissioning. Even worked as a functional engineering in the having experience in developing functional requirements for high-speed train passenger information and entertainment system and diagnostics models, and even having experience with the simulation as a auxiliary power system, lab view for power integration, and display system simulation. And even more points including here the flight display systems as per DO 118B standards and power integration as qualification as per DO 160 bar DO 178B, and even developed test equipment for integrated power model and for auxiliary power system, and even they're having protocols worked with. Here are the details we are having microcontroller as well as the standards they're worked with, and having a very good vast experience. And here I would like to say in a few words, sir has vast experience, even the information is vast, but we are very fortunate that we are having as such a resource person here. So I hope it will be very benefit for all the attendees, especially those who are in the third year as well as in the final year. So I wholeheartedly welcome Rudraradya sir. Please welcome, sir.
Yeah.
Thank you.
And the
Thank
presidential address by yeah. And the presidential address by Dr. Iranna Korajkan sir, who is the Vice Principal of Tontadarya College of Engineering and HOD of Electrical and Electronics Department.
Yeah, I think sir is busy with some other work. Sir will join within a moment or followed by the session, sir session. So I request Rudraradya sir to take over the session. Please, sir.
Oh, thank you.
Yeah,
Thank you
yeah.
all from Tontadarya College of Engineering for entire team for a warm welcome and also giving an opportunity for providing this webinar from my end. Okay, I'll start with my anyway the introduction is given from everyone. Just I'll start with my quick introduction. I'll be sharing the screen. Let me
Yes,
know
sir.
once the screen is visible.
Yeah, it's visible, sir.
Oh, perfect. Thank you.
Yeah.
Okay, yeah. So I'll directly jump onto the things. I'll not take any of much time. Just I'll go with whatever the way I have planned to start the things. Okay. Let me know, and also let it be a kind of interaction. I request if anyone wants any question, can you interrupt me at any point of time, and you can ask your questions and you can raise your points. I'm sure that the prototype process and design is the development what you are given. It's really a vast subject. Okay, because of I can tell every field and every engineering will be having their own way of developing the prototyping, and starting from agricultural to the any of the high-end yeah, till to the space technology, we are going to do the prototyping. Okay, so it is a too vast subject. Let me try to put some light on what the knowledge I'm having or what the way we have developed and what the way we are going to go. It will be just I'm going to tell you, not even less than 1% of information will be provided in next 1 hour. That's what I can tell you. Okay, and this will be the introduction, or sorry, this will be the way I'm going to run the slides for your information. What is actually the introduction of ourselves and what we will be doing, not more than 2 to 3 minutes we are going to take. And I'm going to take an example of what we have done and presently what the way we are following the prototyping, our live example I'm going to give you with some demonstration and things. And also I'm going to try to give what is the planning, why we have to go for the prototype planning, and what are all the what are all things should be considered while planning. That also I'll try to cover up. Okay, and also with the prototype categories, when you are doing the prototyping, what are the type of categories are there, which one you have to select, or what it makes while selecting the things that I'll try to cover it up. Okay, and also stages and the final product effectiveness and advantages of prototyping. Let me try to go with this sequence. Okay, and again I'm repeating, if you have any questions you can surely you can ask for me back at any point of time. Okay, anyway, the introduction is done already. Just I'm going to make a quick things. Almost like 20-21 years I'm working in this industry for aerospace, for basically for starting from a system like engine, auxiliary engine, and also the over detection system and multiple systems we have developed. Presently I'm running my own industry. We are developing a product for Indian Railways, and also for defense we are doing some projects, and also for commercial we are developing, and also we have done a smart battery product, which is totally it's a product. Okay, I'm not telling that we are doing either a software or either one of the part of mechanical or one part of electrical. It's not like that. We are integrating entire product, and we are ready for going into the market. That's the present way what the CED labs and my experience is going to be laying. Yeah, when I come back to the focus about CED labs, okay, just if you say the prototype, everywhere it's a prototype. Till today, what we have done is only prototyping. Okay, one is, as I said, CED, create, execute, and demonstrate, and also the prototyping. Why I took this CED labs, the naming and other things was the demonstration was for basically for prototyping. Okay, prototyping is nothing but first you have to get an idea. Okay, I have to do something like this. Okay, I'm having something to do this. That only it will be there in your mind. Okay, that can be only then that is called as a creativity. Okay, from there you have to go for the executive, how to execute, how to plan it, how to make this really available, and how can we do this one. Okay, that questions is going to come for any of the ideas we are going to do. That's the way you're going to do the execution, and also and then finally you're going to do any negative things are there, or whatever the issues, or whatever the by doing your testing you make your product more robust. That's what the way. And we are also CED labs. As a CED labs we are standing as a CED by doing all the kind of creation, execution, and developing of our product. This will be a brief introduction of our company or of myself. Okay, now let me come back to directly into the prototyping. Okay, now the question is going to come, what actually the prototyping, why we have to do the prototyping of the things. Do you really need anything such kind of process, or directly I can jump into the production of anything? Absolutely. Even when you're doing a small work or small any of your getting prepared for your rehearsal from any, go for any field, starting from drama, your agriculture, you go to any industries, garments, everywhere we have to do the prototyping to make to say that yeah, what our product is going to go is really it's going to be effective and it's going to work out. Okay, to do that prototyping. But every industry is having its own way of doing the prototyping. It is not that okay, the way what the chemical industry will follow, the same thing should be there for electronics. The way how the agriculture system they'll follow, the same thing should be there in other industry. It is not that, but anyway I'm trying to, because I am more experienced or more working as a product development, where we need our mechanical, electrical, electronics, and also software. Okay, this is what is required for us. Let me try to be in this particular field. And also I think looking into the audience, most of engineers are there from mechanical, I believe, electrical, electronics, and also instrumentation and other things. So I'll keep our prototyping only for the electronic product development or electrical product development. Okay, now let me come back to the what actually you're going to do. That nothing but, as I said, first you have to create your idea. Once you got an your idea, or once you get a thought, I wanted to convert that into a digital format. Okay, that I have to convert into from a paperwork to the real format is called as a prototyping. Okay, uh, just a second, give me a second. Okay, I'm having some disturbance here. Just a second. I'm so sorry. Some back-end noise was running. That's the reason I stopped it. I'm so sorry.
Yeah, it's okay. So yeah,
Yeah.
please.
Yeah, I'm back. I think so. Any of your instrument, you have to start from your idea what you are doing. From there, it's get converted into the real product. Okay, that's what we have to start from. That's what the prototyping I can give just an example. That just an meaning of that. Okay, generally used to evaluate a new design precision type of analyst and users. Okay, essential step for prototyping. There are multiple types of technologies are there. When you're again, I'm telling you, depending on your the industry, the way of prototyping format or things you are going to do. For example, when you go for garments, the totally the way of prototyping will be different. When you come back to the agriculture, you no need to follow the same thing what the technology is there. Okay, so there you have to change your thing, but end of the day, its meaning is one and the same. Put your logics or put your ideas first into a one working model. Okay, one convert that whatever it is there in the paper or in your imagination, that into the reality. That's what the prototyping is before going for the production or before going for your looking into your end user or customer, before using the customer getting using your product. Okay, so what you have to do for the prototyping, then what actually you have to start, how you have to start. Okay, I'm going to purely I'm going to consider only your mechanical product, or some only the product where our mechanical engineers are required, electrical engineers are required, and software engineers are required. Only I'm going to take this as an example because that is my what we are having a strength and what I can give you more examples on that, keeping that as an example. Okay, you have at least we are going to do when you are doing the when you are developing a prototype, we are go for at least two or three types of three versions of prototypes. Okay, once when you start, usually initial version, we know that there will be a lot of because the idea is very so raw idea will be there. For example, I'm going to show our pictures. When we started developing the first one, this is the top one, what we are seeing in the orange color. That was the thing, what it was there as a idea, what it came from our product. That actually we are changed into the model. Okay, after coming out, once we started looking into the product, it started looking that okay, it's really bulky. It looks like something what we didn't needed or what we wanted to do. And when you're trying to assembly, we were a lot of issues were there. When you're trying to integrate with your different integration, the screws were in one direction, your hardware was in other direction. Okay, it was totally messed up product. That's what you can see, the orange color what it is there on the things. And when it comes to the next stage, okay, just I'm trying to tell you what are all the why I'm telling you what the planning is required, why the three levels of plannings or three or four levels of versions are required. That's the reason I'm going to give this example. Okay, in second one, I found that okay, the battery was making a lot of sound, and also the holding mechanism was not good, unnecessary. We made a lot of space wasting here and there. So we made one slot for battery. We made an holding mechanism and all of the things we did. Still, it was having a lot of other issue. And you see the last version, what it is that it looks very clean and crisp. Okay, so a raw idea how it is get transforming while making. And again, it is not a proto model which is ready for going for market. Not at all. Just it's a model. Okay, I'll tell you, and it's a functional model. Again, I'll tell you what is a types of proto models are there in next slides. Okay, let me come back to the planning. When you're saying a planning, my preferably I'll go for three versions. Okay, again the proto what is the three version, I'll let you know in the coming up slides. Okay, why we have to take for the first version as a three versions. Okay, and what are all the process will be involved in three versions. Just I'll open my just a planning document. You can use any of your planning document for doing your prototyping. Usually the Microsoft project plan MPP is the one which is the best providable. Very easily you can start making the project plans. Okay, or you can use any of your Excel sheets. Also should be good enough to do your project plans. Okay, when you start with doing this prototyping, if you see that we were having a first prototype, second prototype, and third prototype. Okay, we are done with the multiple prototype. Then only we are gone for this is the prototype testing in the version one, prototype one testing. Okay, next comes is prototype 2 testing, then we are going to go for a release of the things. When you say that, just I like to give, because you guys are in different streams. I mean to say, one is in mechanical, one is in electrical, electronics, and other one is will be software. All three of you should come together to make up any of the product. That's what we are lagging. That's what I understand. That's the reason I'm taking up this 5 to 10 minutes of my time to explain what is the product. It's just not an being a coding, or just it's not than making some CAD product, or just it's not that something I'm going to draw a circuit or a topology. It's not at all like that. All the three engineers put together is going to make a product. So always I wish that our engineers, our students, our coming up young generation should have a mindset of integrating all these three together. That much of data should be involved. So to just a briefing, I'm telling you this less covers less than 1% of entire concept. Okay, still I'm trying to go. Usually what happens once the concept is ready. Okay, what is the first thing you're going to do? Okay, you are going to start with the block diagram. What are the topologies available? What is the controller? What is the what kind of enclosures I'm supposed to use? What is the mechanical structure should be there? Okay, what are all the the interfaces between the mechanical and electrical and the software? Okay, this all these things should be defined when you're doing your concept itself. Okay, with that, when you're starting your concept itself, you can't go into the prototyping, or you can't go into the jump into the things very immediately. Okay, so once you any of the top for that sake, any of your product you take, you wanted to develop a robotics, you wanted to develop any of your new model, these are all the basic things you have to be ready, or you have to give some time in your planning document, so that you are going to make your all. And also, selecting the components, or selecting your you don't go for the final product, at least for the prototyping. Selecting the component itself is a big things, where you have to plan for yourself for doing this concept design. This includes altogether, I mean to say, this includes your mechanical, includes your mechanical engineer should be there next to you, your electrical and electronic engineer should be next to you, and software engineer should be next to you. All together deciding, okay, these are all my interface, I'm going to give the data for you like this. You That kind of chain linking should happen between all the three teams. Actually, from the team, then only you can start doing the concept ready. Okay, next comes is, okay, once the concept is ready, usually review all those things is a part of a corporate process. Just I'm going to put that again, the how you're going to give the document, what are the review documents you're going to provide for your concept. All other things should be as a part of process, it should go, and you're going to do that. Okay, now it comes to I'm trying to give you a brief things what are all is required when you're doing a product development prototyping. That's the reason this was very easy for me to take it up. That's the reason I'm listing out all my things. Once you got what you're going to do as a mechanical, okay, I'm a mechanical engineer, I'm going to do my modeling and I'm going to give you. Is it going to work for you? Absolutely no. You have to make every modeling with interaction with your electrical team or electronic team. Okay, I'll tell you what are all the problems you're going to face usually when you're designing this mechanical team. Okay, the modeling, the detailing, material selection, thermal analysis, stress analysis, bomb preparation, space, a lot of things you're going to do when you're doing your first mechanical things. Basically, you will not be knowing where the shape should be there, where my switch should come, where my display should come, how do my handle should be there, where I should do the handling, fixing. That will be a zero place. That's what I said, it will be a white paper for you once you start that. Then you say that, okay, you will make a first draft, I'm going to give here, where the electrical team come and say, no, if you give here, they'll not do that. Again, electrical team will be having the same condition. They also will be in the same team, that where you are going to give, I'm not going to give that place. The integration will not happen. So that is a big time or big lot of time should be spent in this time, okay, while doing integration between the first concept is one thing. After that, again, the lot of clashes is going to happen between mechanical and electronics and electrical team. This is usually this is the electrical team will be doing this kind of works, okay. Next comes is what the sorry, mechanical team. Next comes is electrical team. What they are going to do, they'll be doing independently again the same thing what mechanical is done. Similarly, they'll start working concept to schematic development, preliminary bomb creation, layout generation, netlist preparation, simulations, footprint, layer stacking, and essay generation and Gerber generation. This is the one things they'll be doing where the electrical and electronics should sorry, electrical electronic components should interface with the mechanical. Okay, both of you something you got adjusted. Next it comes the great thing is again the software. Okay, come on, if you guys are aligned, do you think that software is going to align so easily? Not at all. They'll be having their own issues, and they'll be having their own restriction to get aligned. Probably software and mechanical, no need to discuss. Most of the time the clash will be there, or the tug of things will be there between the electrical and software. The electrical will say that no, I can't give the pin, this pin for you. Okay, software will say, and presently I'm telling you, most of us are only application oriented. Only we know you are having a data with me, just give me, I'm going to develop an app, I'm going to develop whatever the server and other things we are going to do that thing. But we never see that what is the physical layer interactions are happening. This is the place when you develop the product from your own, when you're doing a prototype from the starting, from the prototyping level, there you'll start finding the issues between the electrical and software development prototyping issues. Okay, so these are all the list of planning activities you should take care. Okay, and let me know if you have any particular questions. Surely I'm going to answer when you're talking about the planning. But before starting off your anything, better to use your Excel sheet or something, and any of your tool, and keep your plan ready for before starting your prototyping. Yeah, next one is okay. This is okay. What are the type of now you decided that okay, I'm going to do this kind of planning, and this is my design, and this all the things activities are there. You're listed of all the things. Now after plan is ready. Okay, I am sure that any of the product development you need at least 2 to 3 weeks of planning itself is going to go for you things before you starting anything, any of your product development, prototyping of any of your product. Okay. Next is what are the types of categories is going to be there. Okay, why you and how you are going to decide that okay, I wanted this kind of prototype. Again, I'm telling you, okay, this is only depends on the industry you're going to work. For example, I want a working type. Okay, working type is nothing but it absolutely looks like a final product. Okay, only thing is it may be having some finishing issues or something should be there, but absolutely it looks like a final product where it can be going for the customer type. You can go for some kind of customer testing also can be taken up in the working thing. Other one is the visual prototype where this is a very, I'm telling you, this is a very generic one again. Okay, when you say visual prototype, okay, it will be just all the pictures will be ready, or design will be ready, where there will be no functionalities, there will be no hardware. You will say that okay, Apple looks like Apple like this. Okay, that's it. What is there inside that? It will be a hello, nothing will be there. It will be just an outlook of your product. Okay, and user experience prototype, that will be just something like your simulation or something. It can be done like hey, experiencing, okay, this will be the file, your ergonomics will be like this, all this kind of things will be provided by the user experience prototype. But most of us will go with the functional prototype, being in electronic industry or being in product development, engineering product development, I mean to say. Okay, like again, engineering product development means I no need to explain for the details. Okay, we here where when you say functional prototype, you may not go to the extent of putting all the materials, all the raw materials as required for the final product. For example, I'm going to say like this. Okay, I'm developing a product for defense, or going to develop a product for something like automotive industries. Okay, or I'm going to develop a product for aerospace industry, or it may be any industrial one, or it may be a commercial one. Depending on these kind of sectors, you have to develop a prototype. For example, when I wanted to go for a automated industry, they're having a couple of standards. Okay, my the plastic should not burn. The plastic should be UL approved. My component should be UL approved. Okay, my whatever the display should be having so and so ruggedness and all of the things. That at the same time, when you go to aero, it will be more tougher rules will be there. When it go to military or anything, there will be having a very rugged rules will be there for them, or the rugged standards will be there. I have to follow the Penta 5 standards, or we have to follow the in the aerospace like DO 160 standards. Okay, accordingly, you wanted to do while doing the functional prototype. I wanted to do all these things satisfaction while doing the prototype. Not exactly. Okay, that's called the functional prototype. It looks like a final product. Yes, of course. Okay, but what the material I'm using, it may not satisfy my vibration test. What the material I'm using, it may not satisfy the function of the fire test. Okay, but the product, it looks absolutely like a final product. All the functionalities works, all the things, all the whatever you wanted to try it out, it will be working like absolutely like that. But only thing is you can't operate it in a full energy or full things, whatever the way the final product is supposed to be there as per the customer expectation, or the as per the industry standards. Okay, that is called as a functional prototype. Usually we'll go for functional prototype in engineering before we go for the final product. And also I'll tell next in coming up slides, I'm giving you some of the example how do the functional prototype will be there, and what and all. I'm going to give some of the pictures and other things where real functional prototypes can be used, and how can we come across the other issues or corrections when we are doing functional prototype. Next comes is prototyping stages. Okay, basically, when you are doing again, it's similar to your planning only. Okay, you say prototype 1, prototype 2, prototype 3. It's nothing but the way you're going to give that. The naming is only it's going to matter. When you say initial drawing or prototype 1, it looks like a apparel model. It's only like, okay, I'm going to, for example, when I was working for this, there is a side here, one pictures are here. Okay, this is the concept what we started using this picture, but actually when it came out, it was looking like this. This guy is holding it, right? Okay, it was looking like this actually, because it actually, this whatever the green color or red color, orange color was, right, it is not a real model. Okay, but we made it to work in that direction so that we can feel the ergonomics, we can feel how it looks and how the pain will be there. That's the way we developed, and it's just an we collected from the industry some here and there, and we done this product ready. Similar to that, when you come back to this apparel appearance model, means it's nothing but just it looks like that. There will be nothing in that. We feel we'll try to go, and if any other failures will be there, that analysis we are going to do. Okay, most of the time we'll use our most available components or raw materials, and we'll try to do this model develop. Okay, next is the proof of concept, where that's what is almost like prototype 3, version 3, what I showed in plan. That will be the proof of concept for us. Okay, where everything is working, functionality is working. Okay, and that's what as I said, it will not meet the industry standards, but all of your functions will be ready and it will be working in that direction. Okay. What is next one is alpha prototype, beta prototype, and pilot production. These are all the just it will be having a very thin line of differences. Okay, when you say alpha prototype, okay, I have done all my testing on these things. I can use it for ourselves internally. We can use it and we can do all kind of testing and all kind of workout. And we are executed the prototype for a couple of weeks or months. I tested and everything. Okay, that kind of things. Internal confidence is there. Okay, this product is going to work. Okay, that is the alpha. And beta prototype is the one we tried it external. We applied this workout on couple of customers and we asked them to give the feedback, live feedback with our external organization and all of the things. That is the place where it's almost final to go that okay I can launch it. So that will be the confidence you'll be having when you're going for the beta prototype. Okay. Next is pilot production. Again, you will not be saying that, okay, when you say beta prototype, pilot production, okay, I'm going to go one shot, 1 lakh or 2 lakh number of production. No, you'll say that, okay, I'll go with that 10, 20, 100, 200. But when you go for a pilot production, it should be almost equal to your final product. Okay, that's what the pilot production will be there. You may need to go for all the testing and all other things. What kind of testings or what kind of informations or what kind of testing. I'm going to give you some of those information also in the next slide. Okay, this is a prototype stages. Again, you can decide this you have to include into your plan, or in the plan one of the desired Pluto 1, 2, 3, or when you're going to say what will be there in which concept or which stage you're going to do. This you can add it. It depends on your way of developing the planning and executing according to your plan. There is no hard rule that you have to only follow like this or that. Okay, this is only the way I'm telling you, just to get a knowledge that okay, these are all the processes are involved when you're developing a proto module. Okay, next comes is okay, effects of prototype on the final module. This is a very good thing. Whenever you start you're doing your prototyping, that is the one. I'm sure that at least 80% of issues will be solved in your before you completing your prototyping things. Okay, like example, I'm going to tell. Okay, when you're doing your first level of prototyping, I'm sure that I showed you in first stage itself. What we'll imagine is okay, the battery is like this. I'm going to give this kind of flow and all other things. Okay, but I understood after assembling the things. Okay, I have done a big mistake of putting the battery vertically. Okay, that you come to know only after assembling and using it on the field of or on the inside the module or inside the prototype what you're going to do that. Okay, so that kind of issues, that's what I said, almost 80 to 80% of issues will be resolved while doing your proto module itself. Okay, and also when we started working on these things, we know that when you're working on the prototype module, this is my personal experience, you make sure that you trend to develop your product in terms of production. Okay, I mean to say in terms of production means you usually in college or in our industry or before coming to any industry, what is our thought is okay, get some product or get some wiring and you make some soldering or you make some tightening and you give that. Okay, if you give the product demonstration, that's your completed. Okay, better not to go in that direction. Okay, at least once you make your prototype development, make sure that the fitment is proper, your tightness is proper, your how many when you are using, what is your force. For example, where you are using your laptop every day. Okay, and every day you're going to press your power on button. Okay, do you have any time you thought that what is the force what is the amount of energy, what is the force you're putting on the button? Okay, what is the mass or what is the weight is getting on the button? You have never any time you have thought about that. Okay, usually when you're doing a prototype, you will never consider all these questions or all these things. That's what the things you have to start evaluating when you're doing your when you're starting developing your design. Where the button is the where very oftenly you will be hitting the button in your mobile or wherever it is. Once you hit the button, you will be putting at least 2 to 3 kgs of your energy force on that. Okay, and it should sustain for at least for 2 years. For 2 years means every day, if you are using for at least for 5 to 10 times, means just to calculate for 2 years how much of times it should go, and wear and tear should happen on the button. Okay, so that kind of evaluation should happen when you're doing your prototyping. Okay, that got very clearly we understood that okay, my theory is going to failure. Okay, that basically the mechanical engineers, I'm telling you. Okay, you just, it is not that okay, I'm doing on one module and I'm going to give, it is not at all the things. When you, if you wanted to go with an product mindset, you have to think about what is the when you're designing your handle, when you're designing your display, when you're designing your any buttons, or when you're designing your center of gravity, what should my product center of gravity, all these things can be all these things can be evaluated when you're doing your prototyping. Okay, center of CG, center of gravity, if I go for a drop test, where the drop, now there is a lot of tools are available. We are doing it basically all my products what I'm showing now, it's a 3D printed. We are never gone for molding, we are never gone for any of the final big financial things where we are going to use lot of money, are going to do lots of lot, we are going to lose lot of money. Just we brought one 3D printer and we started developing all the 3D printing activity. By doing that, we evolved with at least I'm telling you minimum 4 to 5 or six versions of development we have done. So what I'm trying to tell is, I'm talking about the mechanical engineers. When you're doing your design, you make sure that the screw, what the screw weight you're going to give, the theory what you're going to read and what you're going to implement on the product will be totally different. Okay, and there is a lot of tools are there to do the analysis of your what the module you have done, what is the maximum temperature which stand, what is the airflow analysis, okay, thermal analysis, and also all these things you make sure how to learn this and how to do this product. Okay, that gives a very good final product. Will be no, there will be no rework on those things. When it come back to electrical or electronics, okay, usually the big mistake what you are going to do in the electronics while doing a prototyping is we'll never think about the connectivity. Okay, we'll say that okay, oh, there is a space here, okay, pull a wire. Okay, always try to do the assembly in such a way that directly the mounting should happen between the PCB and the things where the wear and tear will not be there. Okay, that means this is the learnings what I'm trying to tell you from because I'm not thinking about if at all if there is any experienced person by default they'll start learning this. Okay, when it comes to any engineering or any coming engineer students coming out of engineering, they'll be not having such kind of thought focus or thought process. That's the reason I'm trying to tell you, start thinking about all the minute things while doing prototyping itself. Okay, like what should be the wire, what should be the wire length, start thinking about from point 0.01 mm. From that level you start thinking the accuracy. And presently the technology or the available technology is so good that okay, you can start providing the accuracy of zero point 0.1 mm starting from the prototype level itself. Okay, it is, you no need to wait for going for final product to give the accuracy of 0.1 mm. Okay, so electrical team, surely you should have a lot of other things. Means while developing, you have to read all the, for example, I said electrical, I mean to say, like MOD, means defense requirements or aero requirements or automotive requirements. You go through every requirements and make sure that you're not leaving any circuit. For example, I want to cover a lightning circuit. I wanted to cover a high voltage test, vibration test, all those things you start implementing from the day one of your developing your proto model. Just if you neglect one of your requirement, let me go for the final product, I no need to do this particular circuit now, then you're going to lose something, the big one. Okay, so always you start doing from the day one, including all the circuits, whatever it's possible, start doing the testing on the on the proto module itself. Okay, and also this is going to give a very good insight when you're doing a prototyping is your cost. What will be your approximate cost on your product or final product you're going to get? That kind of analysis can be done very easily when you're doing your prototype. Okay, if you and you try to get all the real version of component, at least not for the first version. Okay, when you're coming to the something beta release or by alpha release, you take all the original components. Don't try to negotiate on the component or anything, because you need a original cost. You have to do the production of the product. That's the reason always you try to give a real pro component, and by this time you should be having a vendor list, you should be having a manufacturer list, you should be having all the real components what you're supposed to do. That should be list should be maintained. Okay, so all this costing should be completed by the time you are going to reach your alpha module, or in the planning wise I showed you as a prototype 3. By that time all this data should be available whom you are going to go for the final production or the pilot production. Okay, and also just I was trying sale of product, it is there. Okay, this is the one little bit tricky, depends on again on the type of industry you're going to look, or type of industry you're going to plan. If some industries they'll say no 3D printed is not at all possible for me if you go for a plastic, because always you look the beautification of the product, how you feel and how you hold it. Okay, but when it comes to the metal or in metal enclosures or anything, it doesn't matter. It will be almost similar. There'll be no difference between the final product and the your beta version of your product when it goes for a metal sheet enclosure or something like that. Okay, that again, sale of a product using the using this prototype is again the optional. It may not work for all the industry. Okay, but yes, you can carry for the sales, and the sales team can surely start working from the time of your beta test or alpha release is ready. They can start working for the selling purpose, and they can start taking for the samples surely. Okay, so this is some of the options of these things, and also this my experience wise, I'm going to tell you that what are all the other tests you should be thinking while before going for the final product. Usually, when it comes to the electronics or any of the mechanical, if you are going for either auto industry, or you are going for aero industry or mill grade, or even what is that, medical industry. Okay, all these guys, they need a minimum things should be passed. Okay, so from the day one you start planning for this kind of testing. Okay, for example, high voltage test, any of your product, if you're using a, you have to go for high voltage test, depending on your what is the wattage of your power. Okay, lightning is the one default if you're using in the ground, in the open space. Okay, so you start developing the circuits and all of the things from the prototype level itself. Don't neglect these requirements when you're doing this prototyping. Okay, next comes is your magnetic effect. That depends on again the product to product. Okay, vibration is must and should for all of you. Okay, please make sure that vibration test is always taken care while is it okay? Yeah, vibration test is always taken care while you're designing your mechanical component itself. Okay, don't wait for let me do the screws or let other things later part and other things. And you know the dust means IP. If you are going for IP product, okay, make sure that your all your IP standards, ingress standards or ingress protection will be done from the day one of your developing your prototype. And of course, you can do the ingress protection test using your 3D model or even your prototype, any of your model that can be done. And we have done already, and that's my I'm telling you with my own experience. Okay. And these are some of the other tests where we have to take care. Whoever is working on the electrical and electronics, the biggest issue will be the CE and RE. I mean, conduction emission and radiation emission will be your biggest issue, and that will be your lifetime threatening requirements. Okay. So whenever you are designing your product, okay, select the components for your prototyping itself right, and from the designing itself you should select your right component with the right frequency, and make sure that your product or your frequency, your harmonics is not going to go and hit your the CA and RA requirements. Okay, this is a big, that's a really a big vast subject, conduction emission and radiation emission. Okay, but this should be taken care from the type of, from the start of prototyping itself. Okay, it is not that okay, once I done my entire engineering or entire designing, then I'll start my looking into CE and RE. That will never work. It always will be in a big circle to resolve this RE and CE issues. If you miss the if you're not giving the important from the day of starting your production prototype designing. Okay, then other things are, altitude test, acceleration test, interest test, all those things you can start. Work temperature test, okay, fire protection test. There will be a lot of things will be there, depending again on your which industry you are going to go for that. Depending on that, whatever this, usually everyone, all of us will run with making the functionality proving first. Okay, yes, that is true. What making the functionality proving is really true. Okay, but while doing a functionality proving, we'll miss all this safety related and quality related issues or quality related requirements. Will miss me. I mean, will totally lose the track. Okay, so you take all the requirement, physical requirement, and integration requirement, protection requirement, safety requirements, functional requirements. Okay, all together while doing your prototype, you take all together in parallel. Don't ever uh, leave any of this requirement back and start going into the for directly hurry to make your completing your prototype and then jump into your production activity. Better not. If you delay for other 1 or 2 months, it doesn't matter, but you have to take all these things, you make sure that all these things have been completed. And also better to go for a customer feedback. I know that you're going to be a big pain because none of the customers will be happy when you're giving a prototype kind of things. Okay, that too beta version of the things. Okay, but still it's okay. We have to go and take the feedback before going for the production in the prototype level itself. Okay, and these are all the couple of advantages of the pro things. Anyway, there is a almost I covered. Okay, provide functionality and interactions. Basically, the big thing is going to be integration issues are there, right? That is always a painful area. Okay, usually, when you say that either mechanical hardware or even the electrical or the electronics and software, you'll never meet each other. I don't know what is the reason. At least I'm able to integrate between software and electronics very easily, but electronics and our electrical and mechanical integration is the biggest toughest part. I'm telling you why, means because they themselves having a lot of constraints. Okay, if you move 1 mm left or right, the entire design changes for mechanical, or if you ask one component to change, means it will be a big process for electronics. Okay, or electrical for that sake. Okay, so that will be a biggest pain for integrating. In prototyping level itself, you can start solving all these issues. Okay, again, detecting error, early error, and time saving. Whatever you do, time saving and money saving will be part of things. You have to do all those things continuously. That will be a continuous improvement will be there always, and depends on the some of the things depends on your experience and how the team is going to think about the failures for future. Okay, involve user feedback and help to do multiple testing. That's what I said. You better to take the feedback consistently on your prototype, and where that's what we'll say, that verification and validation can be done on the prototypes also. Okay, full term of can be done, and we are in basically in aerospace. We are going to do on the prototype. We are going to do all the certification activities. Then only we'll go for the production, production, and all the certification and everything will be taken on the prototype module itself. Okay, reduce time and cost obviously, yes. Improves and integrate increase the user involvement. Yeah, as I said already, these things quick user feedback is available, leading to the better solution. This is sometimes it's good and bad both. Actually, if you go into this cycle, you will be doing a cycle continuously. Oh, this I can do better. This I can do better. Better you stick to your requirement. Never go away from your requirement. Even if you have a better solutions or better ideas, once you are into the requirement, but don't try to change your requirement. That's my feedback. But I know that it's tough. Yeah, you better to be in that direction. Okay. Missing functionalities can be identified easily. This is not only the prototype can be done, but also we have to do with respect to some process related issues like finding a right configuration management, using a right process of review process. Okay, and also finding a right change management process. Okay, all together is going to give you the missing functionalities can identify the easily. This is prototyping is one of the things. When you include all this process into the prototype, surely you'll make sure that you're going to solve all the missing functionalities if you've done anything missing. Okay, only doing a prototyping is not going to help this. You have to follow all the process while doing this prototyping. That's what surely you'll come up without missing any of the links between the software when you're doing your product development. Okay, users are actively involved in development. That's obviously yes. Okay, so this is our total. I think I don't know how much I'm able to give. If I start talking on one subject, also it will be a big thing. I'm going to give you the maximum time for your questions and answers. Whatever you wanted to ask, you can ask me on these things. Surely, I'm trying to cover up a lot of things. Okay, and this is what my total experience on this prototyping part. Okay, just I'm open for all your questions from my end. Yeah, please. I'm there in the call.
Yeah, sir, you are there.
Okay, good enough.
Yeah.
I'm sure that it was a what is this? The quantity is too huge, is there? Okay, I like to ask the questions. Whatever I covered from there, we can give you the lot of insight. I'm telling you, sure.
Yes, sir. Really, it was very really vast, and it was nice going on. Yeah. Any questions from students? Please, you can ask. You can unmute yourself and you can ask. Or if you're having any questions, you can put in a chat box. So we'll take questions so that sir can answer the questions from audience.
Either it's my thing is too over informative or it is not understood something. Come up with the questions. I'm sure that you'll be having a lot of questions.
Yeah, they might be having questions, sir, but always, as we know, students they'll take much time. You want to ask questions? Yes. Yeah, Shrutika. Yes, go ahead. If you're having any doubts, questions.
Yes, sir. So, what kind of works you will give for freshers, sir?
What kind of?
Works, sir, for freshers.
I didn't get your question, Shrutika.
So, what kind of works you will give for the freshers, sir?
Okay, good enough. Yeah, I understood your point. What kind of work as a when you're doing a development activity? Yeah, see, when any of the development activity, when you're doing this, there is again, I said you, it will be a bits and pieces of work will be there. See, when you go for your mechanical engineering, okay, they have to do one particular model design, then it should be stitched with the other module. Okay, when it comes to the software engineering, for example, one should work on the PDM, PWM, one should work on the user interface, something it will be doing on the independently, and we have to do a lot of experiment on particular things. Then we have to go and integrate into the final part. Okay, so when as a fresher, when it comes, they'll be having a lot of creativities and lot of ideas to start implementing. So if you give one concept for them, you come up with hundreds of results or whatever the things you can come up. You bring it up. I'm always we should support them to bring with ideas. Why it may be a coding, it may be a circuit, it may be electronics, it may be a mechanical, whatever that you don't stop them. Okay, give one particular product that depends on the program manager or project manager who is going to run the show. He should be very intelligent enough to say that okay, you go and do this experiment and you come up with these things. Then the fresher engineer, he'll try to be a creative and he'll try to get a lot of things from his work around and he'll get with the best solution. And anyway, the integrator is the one who can decide what will be the best solution, what you are out of 10 or 15, what you have bought, which one to select. The integrator will be able to select it in right way. I answered your point.
Yes, sir. Thank you, sir.
Sir,
Mhm.
on what basic thing we can start the prototype, sir?
Yeah, see, whatever it is now, it's first thing is if you are having an idea, okay, to start your prototyping, just having an idea is not is going to work out. Okay, if at all, if you are having, if you know that this is not going to spend, I am going to spend only 1,000, 10,000 or something, I can start working means that you can start working on that. You have to make sure that there is a right enough funding or finance is there. Okay, you have to make sure that you are having a right resources there. I'm sure that being a alone, I can't be a superman to be a electronics and in a mechanical and also the software engineer one person. Okay, you have to have a right team for that to do that. Okay, who can understand your idea, who can who can convert your idea into a realistic. That team should be identified. Okay, then you have to go for the planning and remaining things will continue. Okay, to answer your one point, yes, you have to keep all the resource ready, then you have to start your prototyping. Make sense?
Okay, sir. Thank you, sir.
Mhm.
Hello, sir.
Mhm.
So, what are the job opportunities we get from that, sir?
There is nothing called as a job opportunities with see every industry in entire India we are doing a prototyping only. Okay, that is the biggest problem what we are trying to solve. It is again in India we are for almost like 20 years or 21 years, I worked for a couple of industry in aerospace. Okay, we always will tend to give the job opportunities in such a way that okay, you need a software, I'm going to do a software irrespective of which platform is going to use, where is the hardware, what is required. You will never know that which what will be the total product. You will never know in any of the industry what we are working. Only few couple of industries will be having an full idea of okay, my this total product and this is the way it is going to look. Okay, so if you say about what is the thing you are going to get only prototyping, you are the person who is going to develop a big industry. Today it may be a one small something like your pen, your mouse, your anything small instrument you start. You're doing your own prototype and you're ready with the entire solution with all the integration logics and also with all the vendors and everything. Okay, you are almost a one industrialist who can give a job for hundreds of them. Okay, so you have to go with the product mindset to think about a prototype. Okay, it is not that okay, I'm a software engineer, I'm going to do only coding. No, you have to have all the three to four even for some extent you need chemical also. Okay, you have to know all these sectors and you have to have a full control of all these things. And job opportunities, I'm telling you, it's a big. Why the China is so much of job is there? Why the China, why it's going up ruling? Because of the product mindset. Okay, I think because of last 2 decades or 3 decades, because of software boom and all other things, we are losing our product mindset. I request all of you, being young engineers, run with the product mindset. Okay, at least we can start instead of bringing an electronics and some other things from outside or anything. We can develop our own product. Doesn't matter if it may fail once or it may fail twice. Okay, for third time it will surely it will pass. And you are going to create a big opportunity, no doubt in that.
Okay, sir. Thank you, sir.
Mhm. Any other questions? I'll switch on my video so that. Okay.
Yes, sir. Actually, I wanted to ask that to take snaps.
Yeah, I forgot.
Yes.
Usually I'll switch on my videos in things I totally have forgot on it.
Yes, sir. Yes, sir.
Yeah. I think you can go ahead and ask. I'm sure that there will be a lot of other things will be there, other questions will be there for you to things. And I think 8th sem or even 3rd sem, whatever you're doing, you start your thinking in a mindset. Okay, nowadays we are having a big opportunities. Okay, why we wanted to get it at least chip level or chip level manufacturing will go slowly. But why can't we make a product level at least? Okay, start thinking in that direction. And also nowadays the government is bringing all the rules and regulations or supporting for the education institute to come up with a mindset instead of doing a product from one just from one stream like computer or electronics or anything all together put together you do the project. That kind of schemes they are bringing it up. Okay, so start thinking together and start developing the product. Just don't go or then don't present your project for the sake of presenting the projects. Just you have to really integrate all these 3 streams or 4 streams integrate together and you start presenting the project. It will be a really good things to start up. At least next 10 years we'll be having our own products in India.
Will it be taken to only patent or any other level
It depends on the type
or
of.
only prototypes?
No, prototype idea itself can be taken into the patent, Sagar. Okay, you can. It is not that only after doing a prototype you have to go for the patent. Just keeping an idea and a theory what you want to do, you can apply for patent and you can go ahead. Okay, so applying for patent there is no start or end. Any point of time, you can apply for patent and you can start working on that.
Okay, sir. Thank you.
Excuse me, sir.
Yeah, tell me.
Sir, how much does it cost to make a prototype, sir?
Yeah, that's a big question. Depends on your product. As I said, as I said that if any product, example, I'll tell you in this way. Okay, I want to make a product with my in the garment industry. Okay, I can feel that there is nothing that I wanted to get the right fabric, right thing, and I wanted to do a model or prototype on that. It may cost less than 10 or 50,000 rupees or even 20,000 rupees. When you wanted to go for any agricultural prototype, it may take a long time, but it's going to give a cost is again it will be minimum. When you go for electronic, because you have to integrate 3 or 4 streams together, the cost may go again. That depends on what the technology you're using, what are all the other things. If I wanted to go for a prototype of any automotive industry, that cost little bit higher end. Okay, it may go for even lakhs together. And again, it depends only about your what the technologies or what the stream, what the sector you're going to select. Since I'm working on electronic and engineering product, that's the reason I took this whatever the product I've taken. Okay, if you tell me the sectors, I can tell you approximate what it may cost. If you've come for electronics, it may start from 1 lakh. It may go for crores also. Okay. For example, something they are developing a prototype for in Hyderabad. One of the company they are developing a prototype for some rocket science. They got funding of almost like 10 to 12 crore funding they got for doing those experiments. Okay, and again they are doing some prototypes are developing for small industries like cycle, bicycles, and all other things. For them, they're getting a funding of almost like 10 lakh, 15 lakhs. Okay, that depends on the sector to sector. There is no any hard rule that what will be the cost.
Okay, sir. Thank you.
How much it costs, sir, if we go through the electronics?
Yeah, again, I answered the same question. If you wanted to go for electronic product, okay. For example, if you wanted to start with PCB manufacturing, you have to do component selection, what type of component, what are the cost of component, okay. You have to develop the design, you have to integrate it, you have to place it assembly, you have to make it test that integrated assembly. That itself is a big process, okay. That may go up to even if you use a PCB of almost like let me say that 4 inch by 4 inch PCB minimum size. If you're going also, okay, you may need to spend up to at least 10 to 15 lakhs to make 1 or 2 prototypes. Okay, for that enclosure, again you have to spend around 2 to 3 lakhs. Okay, I'm not talking about any electronic any particular product. Okay, again, if you use something a technology like what is that chip technologies, you may need to spend a little bit more for those technologies. You have to go for burning, and again chips you have to procure and all other things. Okay, again I'm telling you, for electronics it may start from in 2 to 3 lakhs and it may go till 10 to 20 lakhs. Depends on your project, what you're going to select.
Okay, sir.
Yeah, any further questions? Yeah, fine. Yeah, Shrutika.
Yes, sir. And a vote of thanks by Bhavna from ASM Triple Department.
Thank you, Shrutika. Good evening, everyone. Myself, Bhavna Dalbanjan from 8th and Triple Department. It's an honor to have been asked to offer a vote of thanks on this occasion. On behalf of my college and our entire management team, I am very grateful to our today's resource person, Mr. Rudraradhya Panchaksharaya sir, for sharing his knowledgeable experience with us today. Thank you, sir. And also, I would like to thank our college and EIIC Cell for organizing this event and let everyone gain knowledge. And also, I would like to thank all the participants for attending this online workshop. Thank you all.
Yeah, thank you. Thank you, even Shritika, Bhavana. I thank all the organizing committee, as well as especially I thank our beloved principal, Dr. M. Auti sir, as well as Vice Principal Dr. Iranna sir. Actually, he was busy, so couldn't able to make join here. So I especially thank our today's resource person. Thank you so much, sir.
Thank you. Thank you.
Yeah, sir. Definitely, it was really brainstorming, especially for third year and final year. Actually, they are working on projects. Really, what actually the prototype? It's a means. Really, it gives a meaning for them.
Yeah, sure.
Yeah. Thank you, sir. Thank you so much. Definitely, we will have some more sessions in future. We will have always we will be in touch with you, sir. Thank you, sir. Thank you so much.
Thank you all. Thank you
Yeah.
for all for providing such a
Yeah.
wonderful
Yes.
opportunity. Have a nice day for all of you.
Yes.
Bye bye.
Yeah, sir. Thank you.
Thank you, sir. Rudradya sir. Thank you, sir, for being with us.
Yeah, participants, feedback link will be shared. I think it will be shared in the WhatsApp group. No need to worry. You'll get the certificate. Yeah, please fill the feedback link. Okay, thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Yeah, thank you, Hazra. Actually, I forgot. Thank you, Hazra. Yeah, thank you so much.
It's okay, sir. Thank you.